Hello, welcome back to Piers Rocks. Today I'm going to lay out a USB version of this extremely space constrained RP2350 board. Those of you who've been following the channel for a while know about One ROM, the software based retro ROM replacement that's designed for the ultimate in flexibility. I have both STM32 and RP2350 versions today. I recently did a video where I got a USB variant of the STM32 based One ROM working. I now want a USB variant of the RP2350 based One ROM. This non-USB variant was by far and away the most space constrained and most difficult two-layer PCB I've ever laid out. So I've been putting off adding USB onto this because it requires taking up more real estate with components and getting tracks through spaces where there simply aren't tracks on this design today. So I knew coming into this that this would require a complete redesign of this layout. This video is a bit different in a number of ways to my usual videos. Normally I record the intro up front, I then record the video, and then I record the outro at the end. This time I've actually done the full layout of the USB based RP2350 board. So I'm now coming to introduce the video with the knowledge of what the whole journey looked like. And that leads me on to the other way this video is quite different. The majority of this video is me laying out components on the board and routing traces and talking about the difficulties that I'm finding as I'm going along. So it's very much me thinking and solving problems and hitting more problems as I go. It's also a pretty long video. The entire edited PCB layout segment is about 2 hours long. That's collapsed down from about 8 hours that it took me to relay out this board with USB and about 4 hours of footage that I recorded during the process. But if you want to understand how at least I go about routing an extremely difficult space constrained two-layer board, then I do think this is the video for you. As ever, if you find this video interesting and useful, please do consider sticking around for the next one. I hope you enjoy the video.
First thing I need to do is make the changes to the schematic. In particular, I need to add all of the circuitry required for USB. So that was three things. I need the connector itself and some electrostatic discharge diodes. I need the power feeding functionality with two Schottky diodes to make sure that the two different 5-volt supplies don't backfeed each other. And I can't remember what the third portion of the USB schematic from the STM32 was. Got in my head there were 3 bits. So I need that third bit in there as well. And then I need to connect the USB connectors into the RP2350. At this stage, I'm not going to bother connecting up the 2 unconnected GPIOs to header pins because I'm going to have to completely rip apart all of my routing and probably start from scratch. And therefore, I don't actually know what pins on the RP2350 are going to go where on the PCB at this stage. I'll figure that out once I start looking at the layout. Okay, so here's the schematic as it was for the revision A PCB, and I've got the STM32 schematic open on the second monitor here underneath the camera, and the third part of the schematic was the crystal oscillator. Now I don't need that here because I've already got a crystal on the RP2350 board, and that can be used to clock USB as well as the processor. So I only need the 2 things. I need the connector with the electrostatic discharge diodes, and then I need the power circuitry. So the first thing I'm going to do is just literally copy over the appropriate sections of the STM32 schematic to this schematic. I don't quite know where they're going to go yet because there's not quite enough room on this, but I'll figure that out later. I'll probably just squeeze everything together a little bit more, rejig it to give room for this. So now I just need to sort of look and muse at this for a little bit. Okay, so where is my VBus? So my VBus is here, D plus and D minus are here. So I'm going to need D plus and D minus going into the chip. So I'm just going to create labels for each of those. Another change I need to make that I didn't think about is I need to remove some of the existing test points and jumpers. Now, this is the existing programming header on the Rev A board. I'm going to need to do away with that and move all of those things over to test points. Stick that over there. This is the image select pin header. You can see I've only got 3 GPIOs connected into that. These 2 are not connected. So I need to retain that. Obviously it may need to change. I've got boot time select jumpers. Okay, these are the X1 and X2 pins, which are next to the header pins. So I want to retain those. And this is just a 3.3 volt pin on the board, which I'm probably going to do away with because it's going to get in the way of the USB connector. And I can get rid of that, and I can get rid of that. Right, okay. So test point wise, I'm just going to copy over what I had on the STM32 schematic. So by default, I'm going to do the same thing. There is one difference. Copy that, paste it in here. Right, so these are the test points. Oh, I don't quite fit. Yeah, I think that's probably better actually. Right, so move those over to here. Now, there's no MCO on the RP2350. This is a test clock output pin, but you can configure, I think there's like 2 or 3 of the RP2350 pins you can configure to be clock outputs. So I'm actually going to leave this in the schematic, and I may or may not end up connecting it to anything. We'll see how I get on. I don't need boot 0. That's actually called boot in this schematic. And NRST is called run in this schematic. That's just the different pin namings between the STM32 and the Raspberry Pi RP2350. Still needs SWDO and clock. And I've got a couple of 3 volt 3 pins. Alright, that looks good to me. So I've got run, I've got boot, and I've got the SWD pins. So I can delete what I had previously. I can also get rid of this external 3.3 volts. Now the next step is I need to figure out where these are going to go on the RP2350. Now I'm pretty confident that D plus is going to go to USB DP and D minus is going to go to USB DM. But I will check the datasheet because it would be sad to make an error here. Also need to figure out what I'm going to do with VBus. So I'm going to go away and I'm going to read the datasheet for a bit and just figure out what I'm going to do with that VBus. I have the RP2350 datasheet open in front of me, and I found the bit of the datasheet that talks about VBus and detecting VBus. And essentially the model is that there is no dedicated VBus detect pin. There isn't on the STM32 either. It's just one of the GPIOs is used. And it's the same here, but you can use one of multiple different GPIOs on the RP2350 to detect VBus. You can also enable VBus, but this is only relevant when the RP2350 is acting in host mode, i.e. behaving like a PC generally would. I'm not interested in that. The One ROM will always be a USB device, so I just want to detect VBus. So I need to go through and figure out which pins can be used for this. If I use one of the dedicated pins, then this says I can set a bit in SIE status to hardware register, and that will raise the specific VBus detect interrupt, which is what I would like. I don't think it's crucial though that I use one of the pins that can operate in this mode. I think I can use any of the GPIOs if I want to. I can just essentially have a generic interrupt raised if the pin goes high. I don't need to use this specific VBus detect one. But anyway, I might as well use one of the GPIOs one of the appropriate GPIOs if I can. And there's a big table here that shows you all of the different functions for each of the different GPIOs. And some of the pins can operate as VBus detect. So we can see that pin GPIO 28 can operate as VBus detect. That might be one of the 2 spare GPIOs, or one of the 2 GPIOs I failed to route on the revision A board. So I need to just go and double check on the schematic. So pins 24 and 25 are actually the pins that I failed to route the first time around. And pin 25 can operate as a VBus detect pin. So for now, I'm going to connect VBus up to pin 25 in my schematic. But I also need to consider the Raspberry Pi's 5-volt tolerance at this stage. So I believe pins 0 to 25, are 5-volt tolerant on this chip. 26 to 29, which are also ADC pins, are not. So 25 should be good to connect VBus to. Except there is a problem with RP2350's overall 5-volt tolerance for this application, which is the pins are only specified as 5-volt tolerant if you have 3.3 volts applied as power to the chip. When 5 volts comes in over USB, with what I'm proposing to do, that will immediately connect to GPIO 25. It will also go through to the voltage regulator if it's not being powered by the host, and the voltage regulator will turn that 5 volts into 3.3 volts, and that will then power the RP2350. But 5 volts is going to get applied to pin 25 before 3.3 volts. So there's potentially a window there where I could be frying the GPIO pad 25. Now this is already a problem for One ROM, for the chip select lines, where they might be pulled high on the host, and therefore when you plug the chip in and turn the host on, there's a very small period of time when the chip select line is being pulled high to 5 volts, but the voltage regulator hasn't stabilized, isn't generating 3.3 volts for the chip. So at least for the USB supply, I would like to do this properly, and that's probably going to involve putting maybe a resistive divider in place, just so I can feed in 3.3 volts. Now that's 2 extra resistors. Yes, the 0402 resistors are pretty small, but every square millimeter counts on this board, so need to think about what's the right thing to do there. But anyway, pin 25 is what I'm going to use for VBus detection. That's going to mean that I only have one spare unconnected GPIO to route, so the RP2350 board will only get 4 image select jumpers and not the 5 that the STM32 version has. Not sure there's any way around that, but as I go on I might figure out something. Back to the schematic. So let's get rid of spare 2, move VBus over to connect to pin 25 instead. Just double check, I do want pin 25. Yeah, VBus detect, right, excellent. So yeah, I've connected it directly, need to figure out whether that's the right thing to do, but I'm going to go and delete spare 2 from here because it no longer exists. And because I'm pedantic, I'm going to move this up to there. Right, good. So I've connected D plus and D minus. I'm not going to double check the datasheet at this point to see if DP is really plus and DM is really minus. I'm just going to assume it is. Yeah, assume makes an ass out of you and me, I know. This all looks good to me. This all looks good to me. It works on the STM32 board. I don't have a vhost yet on this though. So the supply that comes in from pin 24 on the ROM socket is vhost. So I'm going to need to go and put that in place. This is the ROM socket itself. So this no longer powers 5 volts directly, it powers vhost. And then vhost comes through the Schottky diode and powers 5 volts. The same with VBus. It comes through a Schottky diode and powers 5 volts. So what I've decided to do for now is put a resistive divider in for VBus rather than feeding it directly into GPIO 25. I could stick a series resistor in there with a really high value like 100 kilo ohm, and that would probably be fine. But I think the resistive divider is doing it properly, and I'll just use a pair of 10k ohm resistors because I already have 10k on this board. And that will cause 2.5 volts to go into GPIO 25, which should be fine and safe and is well above the 2 volts required to sense that as a digital logic level high. So that's what I'll do now is I'll stick in the resistive divider. So I'll find an existing 10k resistor, put it in, duplicate it. You'll notice at this point my whole schematic is really quite a mess because I've not got enough space to do any of this. I'm going to figure that out later. I want to get the schematic down, I want to make sure all the footprints are assigned, and then I want to start on the PCB routing. I'll probably basically finish the PCB routing, or at least confirm that I'm confident that it's going to work before I come back and tidy up the schematic. There's no point making a tidy schematic until everything else is done. So I'll feed VBus into the resistive divider. And what is this? So this is 20 kiloohms that VBus is going to ground, so 5 volts at 10 kiloohms. V equals IR, I equals V over R. So 5 divided by 20,000 is, I don't know, 25 microamps. That doesn't seem like a massive drain on the USB bus. So at this point I need a new label. I need VBus detect, and this is an output here. So strictly I should put it on that side. Tidy it up a bit. Right. And then I need VBus detect going in here. That should do me. So I think the schematic is now basically done. So I'll run the, actually I'll check the footprints assignation. Check that I have footprints assigned to all of my components. Yeah, I didn't show you the footprint assignation, but it all looked fine because when I copied the components in from the other schematic, it already had the correct footprints assigned. So the next thing to do is to run the rules checker. Yeah, so that's all good. So I'm happy with the electrical rules checker. Just delete the rules, delete all markers. Right, fine. So the next thing to do is to switch over to the PCB, which I'll do now. So here's the Rev A PCB. First thing I'm going to do is I'm going to pull in the additional components to this PCB layout. And it's given me a whole bunch more components. Now I can immediately see that there's a component missing, which is the micro USB connector has not come in for some reason. So I need to go and figure out why that is. But I've got all my test pads. They're going to end up being on the underside of the board if I can fit them in. So I'll flip those over, stick them on the bottom of the PCB. Right, that's done. These are my 2 resistors for the resistive divider. These are my electrostatic discharge diodes. And these are the 2 diodes for the power supplies. One coming from the host, one coming from the micro USB connector. So let me go and figure out why I don't have a micro USB connector. Now this actually allows us to see why this is going to be a fairly difficult task. The micro USB connector, if I overlay it over the existing programming header, is larger. It's not very much larger, but it's still larger. On the plus side, I can actually route some traces through the middle of it. Some other things just to call out. So these are the 2 USB pins here. You'll see on the current design, there's literally no space to get those pins out of the chip. They have to come out this way because all the power routing happens inside the chip. And okay, maybe I could move components over enough to get one additional trace out, although I'm not sure. I don't really have the space on this side. So that already tells me that I'm going to need to do something fairly drastic with this board. And the thing I'm planning to do is rotate the RP2350 round by 180 degrees. That's going to do 2 things for me. It's going to mean that these 2 pins actually come out at the bottom of the PCB here, which is where I want the micro USB connector to be to match the STM32 version. But I'm hoping that it also gives me a bit more width to play with down here. Now why would that be? If I'm rotating the RP2350, this is the flash chip here. So this is the, I think it's 2 megabytes of flash storage for this chip. And that's going to need to move to the bottom as well, as is the internal voltage regulator supporting circuitry, which is this piece here. It's going to need to move to the bottom of the chip. This is not. This is the external voltage regulator. So this takes in the 5 volts from either the host or the USB, turns it into 3.3 volts for the chip. I do not need to move this down here. I can leave this up here. I am going to have to move the oscillator up here, because you see the oscillator comes into these pins currently on the bottom of the chip. It's going to rotate 180 degrees. This is going to need to move to the top. But that's fine, because when I've got rid of this circuitry, there'll be enough room for the oscillator to go up there. I've got another possibility which will give me a bit more space here as well. These are the X1, X2 pins for the board. So these are what you use if you want to serve multiple ROM sockets simultaneously from a single one ROM. You put a flying lead from one of the chip select lines in the empty sockets into one of these, and another one from another socket into the other one. Remember, it looks like we're only going to have 4 image select jumpers. I've got footprint here for 5. 3 are currently connected. I'm hoping to connect the other spare one. Spare 2 I've had to use for V-bus detection, so I'm not going to be able to pull it out here. I could potentially move these up to here, or free up this area of the board. More likely free up this area of the board, and then I can stick some stuff in here as well. Why don't I want to put this in here? Well, there are some modes of operation where you actually want to jump X1 up to this ground pad here and X2 up to this ground pad here. I think that's done when you're doing dynamic bank switching, so you're dynamically switching the ROM that's being served by one ROM on the fly. You use the X1, 2 pins, jumping them to ground. And yes, they're sharing the ground with the image select jumpers. It's just because, well, I've only got a limited amount of space on this board for ground pins. So anyway, my main plan is to rotate this chip around 180 degrees. And this circuitry, move that down here as well. The other thing I'm going to have to do, and I'm hesitating to do this because it's so depressing, is I'm going to have to delete all of the tracing, all of the routing on this board, because it's going to have to all be done completely from scratch. There are a few bits and pieces that maybe I can keep, like the power routing. See this big fat trace here, and this big fat trace here. Maybe I can keep those, but I'm just not sure it's worth it. But it's heartbreaking to delete all these traces given how long this took to route, and it's also a kind of point of no return. Once I've deleted these traces, they're gone. So just give me a moment. I'm not ready to do that yet. I'm going to move the silk screening out of the way. This is all going to need to change. This is going to need to be revision B. I put a P in front of it to indicate that it's a Raspberry Pi RP2350. I should probably put an R in front of it, actually. I don't know, I'll come back to that later. Let's have a look at the silk screening on the bottom. Get rid of that, get out of the way. I'm going to leave the silk screening for these header pins, these jumper pins up here, and the X1, X2 pins, because I'm hoping they'll stay where they are. That can move. That is B. And these are, I'm going to keep these. I'm going to move them out of the way. I'm going to keep them because if I use the test pads, I'll end up using those. And also, this is a tiny little rectangle on the underside of the board, which is all white. It's all silk screened white. And I include these on every PCB I do if I have space, because it gives you a small amount of space to use a fine tip Sharpie like this to write some kind of identifying mark onto the board. You know, you can write a code, or maybe if you've got enough room, you can write the ROM image that you flashed to this particular chip. I find having those is really, really useful, rather than just having these random circuit boards lying around and they're quite generic and you've no idea what they're actually doing. Anyway, I've got rid of all the silk screening. That's off the side here. Just get it out of the way for now. And let's remove the traces. Now, it's not as bad as I'm sort of making out, because I can open up the old PCB design on my other monitor here and copy from that if I want to. The thing I want to leave untouched, though, is I want to leave all the power routing untouched. I want to leave, it took me quite a while to get the zones built into KiCad to actually give me this 1.1 ring around the chip and this 3.3 volt ring around the chip, and also to have all of this voltage regulator circuitry done correctly. So I'm going to leave that. I'm just going to delete the traces. So there's a box in the bottom right of KiCad, the selection filter box, which you can't see because I've only included a certain amount of the KiCad window here, where you can tell it what types of objects you want to select. And I don't want to select anything other than tracks and vias at this point. So I've selected just tracks and vias in that selection filter box. And that's everything. So I'm actually not going to delete them at this stage because I can't bring myself to. I'm just going to stick them out here. But it gives you a really good idea of actually how I've solved some of the routing challenges. In particular, this is a 5 volt trace, and right now this brings 5 volts down from the pin 24 of the ROM, which comes from the retro system, all the way down to the programming header. We're still going to need a trace like that because we're going to have 5 volts coming in, going from USB, going through a Schottky diode, and then going to need to feed back into this voltage regulator here, and you can see 5 volts is getting fed into it like that. On the STM32 board, the way I modified it was I basically put the Schottky diode for the host supply here and the VBus supply here, and then they basically both came into here and then fed over to the voltage regulator here. So I'm probably going to keep that very similar in this design as well. Anyway, I've got rid of the traces, so I'm close to wanting to lay this out, but I now need to rotate the RP2350. Now, I'm not sure that I want to rotate the RP2350 itself, because that would also mean selecting the flash chip and all this voltage regulator circuitry and spinning it around. The other thing I could do is I could select everything else and spin that around. I'm going to get rid of... I need to change my selection filter so I can select objects again. I'm going to get rid of all of this. Now that is probably a bypass capacitor, I would have thought. I'm going to need to figure out the bypass capacitors later. This is the oscillator. These are components associated with the oscillator. That's the oscillator circuit. So I'm going to move that out of the way together. We've got bypass caps. Is that a bypass cap? Yes, a bypass cap. These are... This is the run resistor on the run line, which I think connects into the flash. It's also going to need to connect into one of the test points. This is also to do with the flash. It's on the boot line. And this is also on the boot line. So I'm going to keep these three together. This I can delete because we no longer need that. This we can delete because this isn't part of my schematic either. I want the voltage regulators to stay roughly there. That stuff I want to move. Now, because of the way this voltage regulator supporting circuitry is laid out, it's a combination of traces, which I've managed to delete, and zones to give me these fatter bits, which is how Raspberry Pi recommends you lay this out. Okay, I think I can select all this stuff and then just rotate it around hopefully around the center of the RP2350. So I'm going to get these bypass caps just out of the way. That's going to need to come with us. That needs to go there. This is just a regular bypass cap. This is to do with the voltage regulator circuit. So that one's going to stay there. This one's going to come out of the way. That's just a regular bypass cap as well. These are regular bypass caps. Oh, yeah, so I'm going to move all the bypass caps down here. And I'm actually going to label it. Okay, well, this is going to be on front copper, which is probably not what I want. But I'm only using this label temporarily anyway. Bypass caps. Just so I remember what they are. So these are the bypass caps. These are boot run. And this is the oscillator. I'm not usually this organized. when laying out a PCB, but I really think it's necessary here. Now these are the resistors to do with the resistive divider. So this is V-bus detect, V-bus det, excellent. Get them a bit out of the way. This is, I'm just going to stick this over to here with the USB, and these are with the USB. Actually no, one of them's the host Schottky diode, which can go up there, and this is this one. Going with USB. Right, excellent, good. Got rid of my bypass capacitors. Nope, one more to go. Now I'm actually going to line them up based on the voltage, because some of them are on the internal VREF 1.1 volts, and some of them are 3.3 volts. Now I thought we had 4 on the 1.1 volts, but I'm probably misremembering it's one of these ones. Yeah, there's 3 in the schematic, plus the actual supporting circuitry. There's a 4.7 μF, which is C16. Which one is it? Where's C16? Oh, it's one of these ones, isn't it? Yeah, so we've got C16 and C17. Right, good. So that stuff right. So I also need that. Okay. Now, saving it, I'm just going to move these. Yeah, so that's it. That's what I want to move. So now I'm hoping that if I rotate it with my crosshair in the middle of the RP2350, it's going to rotate around the center of this chip, because I don't want this chip to move. I just want it rotated 180 degrees. No, it didn't. So I'm going to go and put it back in the right place, which I can hopefully do by lining up with this. Well, that's about right. Let me just redraw the zones. Right, I've still got a 1.1 volt ring, and I've still got a 3.3 volt ring. So hopefully that's good. I mean, I can move this microscopically if I need to. It's not perfect, but it's pretty good, and I'm sure it's fine for my purposes. However, I've just realized that I'm probably going to want to move the RP2350 up, because there's going to be spare space in this area here, and I'm going to be fighting for space down here. That's going to mean moving all this zone stuff, which is going to be a massive pain, but it's going to need to be done. So the next question I have in my head is, well, how much space do I need here? What's going to go up here? The voltage regulator is going to go up here. What other pins do we have? The crystal, right? Yes, of course. The crystal oscillator is going to need to go up here. Let's go and slap that in so I don't forget it again. Right. I think we can get rid of this silk screen because I can remember that now. So I don't really need to squeeze anything more in here. So what I'm thinking is how do I use this space most efficiently? So there's 3 bits that need to go above the RP2350. There's the voltage regulator, which is here, needs to go up in this top left corner. There's the oscillator, that's connecting into, where are the oscillator pins? Those 2 pins here. I'm going to want to tuck both the voltage regulator into here and the oscillator into here if I can. And that's how I've done it on the STM32 USB board. I've got a voltage regulator and then the oscillator next to it. And I'm actually going to bring up that layout in this other monitor, so I've got something to crib from. And then I can stick these additional passives either here or in here. I'm hoping I might be able to squeeze them in here, right? And then I'm also going to need this diode, this Schottky diode, to go in here somewhere. But this should allow me to really squeeze the RP2350 up quite tightly against here. But I've still got to worry about leaving enough space to get the traces out from these pins on the top of the RP2350, like these data lines. There's going to be enough room for them to come out, drop the vias through, and then go to wherever they're going to go. So I don't want it too close. I want enough room for vias. So hopefully that will make sense. But to summarize, I'm looking at this, I'm thinking, how am I going to most efficiently use the space that I've got available to me? Obviously, this micro USB connector is going to go down here somewhere. I'm not going to put it in place yet because it's overlapping with everything. This is going to be the busiest area of the PCB because I've got the USB to put in there. I probably want to keep the LED down here as well. It's quite a nice place for it, but that's that's a Wibney. Wouldn't it be nice if? I've got the internal voltage regulator circuitry that has to go right next to these pins on the RP2350. That's non-negotiable. And if possible, I want to move them over right a little bit so they're not, so I can use slightly thicker traces because it's laid out slightly differently from the reference design here on the previous design. And this flash chip also needs to stay here because the flash pins are, you can see that they're these pins here. And then at the top here, I've got a voltage regulator to fit in, an oscillator to fit in, and then a bunch of passives, basically, and a Schottky diode. I need a little bit of space here to drop the data and address lines that come out of the top of the chip through the board as vias, and then take them off to wherever they need to go. I might need to change, I'm definitely going to need to change the individual address and data pin assignments to make them route easier. That's fine. A PCB revision is defined by a JSON config file in One ROM. So if you change the pin mapping, you just change the JSON file, build the firmware with that new JSON file, and hey presto, it all just magically works. Quite pleased with that. So I'm going to need a little bit of space there, but I can scoot up the RP2350 really a bit further up the board, and that will give me much more space down here. And you know what? I might even fit a USB-C connector on the RP2350 version. Wouldn't that be nice? I think one of the challenges of the USB-C is it's not only a larger footprint connector, at least the ones that are available on JLC, but it's also, I think, requires at least one additional resistor, so that's another passive to fit. But the RP2350 board is not really short of board real estate. The key thing that I'm struggling with the RP2350 is room to route my traces because of all of this power nonsense under the RP2350. I just can't route anything on the top side of the board under the chip. Alright, so I'm busy staring at this, figuring out how to solve my problem. So again, I'm just trying to figure out whether I can get all of the pins on this side of the RP2350 out and drop through to vias, because I'm almost certainly going to need to take them on the underside of the board to where they need to go. And I can't. I just can't fit a via in there because of this bypass capacitor. This needs to be close to here, this pin. So I don't really want to move him. I can't move these traces because these have to come out, and they're already going over as fast as they can because this one has to go here, then this one has to go here, and so on. So there's a number of solutions that occur to me. One is I can move the RP2350 sideways a bit, but that probably breaks this routing, and it also gives me less space on this side of the chip than this side of the chip. So that's a no-go. I can move the chip down, and that will give me more room. That will solve the problem. But I don't want to move the chip down because I want as much room down here as I possibly can. So I'm busy thinking to myself, is there any way I can get this bypass capacitor in a slightly different location and to allow me to get this trace out? And I don't think there is. Fundamentally, I think I need just enough room to get this trace here instead of veering there to go up between here and here. And that's going to need to drop this chip down actually by a fair amount, and that's going to be wasted space, and I don't like that. But I don't see an alternative. I think it is what it is. Right, I've got all of the traces now pulled out and dropped into vias. The way I did it was I moved the chip down. I don't know exactly. I think I'd had to drop it down about 20 milli-inches, so about 0.5 millimeter, in order to essentially give me enough diagonal room here to get an additional trace and clearance through. But I've now got everything pulled out and dropped into a vier. Yeah, it's not right because the traces aren't properly connected. Fine. I've proved that I can do, in fact I've proved it's possible to do all of the routing on this side of the board. So now I need to go and look at all of the other sides of the board. The one I'm going to look at next is the bottom of the chip. I'm going to sort out the voltage regulator and the flash circuit. Now I'm slightly concerned here already. And the reason I'm concerned is I've put the micro USB connector where it needs to be. This is in the middle of the board and it's at exactly the right, I don't know, up down position. What's that, Y position as it is on the STM32 board. So it sticks out about three quarters of a millimeter on that board. I think that's fine. Yes, it overhangs the socket just a little bit, but I think 3/4 of a millimeter, I don't think anyone's going to argue about that. But the voltage regulator supporting circuitry does not fit, because this inductor is right up against this already. I think they're overlapping. Well, KiCad doesn't think they're overlapping, so maybe they're not, but they need to move down just a bit because I've moved this chip further down the knees. So I don't know how I'm going to solve this, because the RP2350 reference design is very clear that you need to lay it out as close to this as you possibly can. In fact, these components here should be slightly over in this direction, and that's okay. I mean, I don't know, maybe that means I can get them a bit closer to the RP2350 and it's all going to work. But that's my next job, is to get the voltage regulator, the internal voltage regulator supporting circuitry in the right place. And then I can think about the flash. I mean, I'm just going to put the flash out of the way. I don't know, I'll just stick it here for now. Come back to that. It's the internal voltage regulator circuitry that I care about, which does include this bypass cap. This bypass cap needs to be super close to these two pins here. Actually, I'm just going to make an executive decision and turn that round right now. So that is going to feed those pins. These are my USB pins. I have to make sure that I don't stop those coming out. I'm going to pull those out right now, this second. In fact, I'm going to pull them out like this. So well out of the way of the voltage regulator, or as far out of the way of the voltage regulator as I possibly can. Right, so that's my USB connectors. Great! I've got those out. Now I need to scooter this supporting voltage regulator circuitry over to the right and get it as close to the RP2350 as I can, so it doesn't impinge on this micro USB connector. So that's the next job. I'm pretty happy with this. I've moved this voltage regulator supporting circuitry over, so it's now actually better replicating the reference design. My traces have to go less sideways than they did before. I've got these, I think they're caps, and the inductor slightly closer to the RP2350, and that's given me a little bit of clear space between my different keep outs for the micro USB and the inductor. It's a little bit ugly looking at the moment. My islands for the various different grounds and 1.1 volts and so on, but I'm pretty confident that this is going to work, and I can come back and tidy everything here up later. And obviously I've even got the 3.3 volt bypass cap here wired up. Now you might be thinking that, isn't this just a little bit too close? And that is a concern, because I have had to come in and touch up the pads of the RP2350s on some boards from JLC. They don't seem to do perfect fabrication with their basic service with the RP2350, and about, I don't know, 10 to 20% of the boards need a little bit of touch up. But there's enough room for me to get my soldering iron. The chip comes to about here, and there's actually plenty of room between that and this capacitor to get my soldering iron, just to run along with a bit of flux all the different pads and make sure there's solder connecting, and I can do it up the sides obviously as well. So this is fine. This should be a good physical layout. I haven't done anything with the flash chip yet. I think ideally
I would put it something like, I think I'm going to have to put it like sideways. I'm just sort of thinking, do I turn this bypass cap round, rotate it by 90 degrees and have it running this way? I think I'm going to do that anyway, just for, I think it's going to be more aesthetic doing that. But I think this flash chip is not going to be able to go in this orientation. I just don't think there's enough room. There might be enough room to get the traces. I'll have a play and leave a big space here, or whether I'm going to have to rotate it. But right now, everything looks pretty good and it's not very space constrained. And the RP2350 board doesn't have as much stuff on the top of the PCB as the STM32 board, right? Because the chips, the RP2350 chip is smaller. The real challenge is getting all the traces routed, particularly on the underside, because you have to route them on the underside because you haven't got underneath the chip on the top. But right now, I have a reasonable level of confidence that I'm going to get this laid out. So we'll see if that comes back and bites me in the rear. Got the flash chip wired in. I think it's going to have to go here in this orientation. There isn't really enough room if you put it in this orientation to get all the traces around it. They end up hitting these pads of the micro USB. I actually tried putting it at 45 degrees, but that's also pretty tight in this space. So I think this is the right location for it, the best location for it. I don't want to put it up here because I'm going to have to get these traces out. But these two resistors are related to, these are boot resistors. These are related to QSPI SS, which is here. So these resistors ideally need to go up here. Now, there's going to need to be a bypass cap here. And I'm going to need to get these traces out. It's all going to get a bit fraught there. So I'm actually going to move this flash chip down and then put these resistors just in here. So I can still get the traces routed around the flash chip okay, but I've just got those resistors in there as well. So I'm going to do that now. So I've got the flash chip and the resistors where I think I want them. I can bring SS down there and then up into there. So that's pretty good. And SDI1 goes there, SD2, SD0, clock. Oops, that's gone way down. That's a bit better. And then I know it fits. It fitted through before. There we go. So I can no longer get this trace in between D5 and the other trace because I've moved the whole thing down. I can't move it any further across. I must be really close to fitting through there. It must be like 1 mil out, maybe 2 mils out. Now I can drop it into a via. I'm trying to avoid dropping it into a via because it might affect operation of the flash at really high speeds. I think this flash chip runs at 125 megahertz, 133 megahertz tops. I think that's the speed we're talking about here. So to be honest, having slightly longer traces and vias in there, I doubt it's going to make any difference. Again, I'm not an expert on this stuff, but that's my gut feeling. To get it routed now, I'm just going to drop a via through the board. What I'm slightly more concerned about is getting 3 volts to this thing. Can I put vias in here? Yeah, so that's how I'm going to get boot to a test pad. And that's now 3.3 volts. So I've now got 3.3 volts to these pieces. Again, this is unlikely to be my final routing, but I'm just getting everything connected right now. I'll come back and sort everything else out later. Done a little bit more work down here now. I've put the Schottky diode just as low down as it can possibly go, with enough clearance between the pad and the edge of the board, which is 15 milliinches. I've put the electrostatic diodes immediately above that Schottky diode. That's how it's laid out on the STM32 board. On the other side, I've moved the LED down just as far as I can get it. and that's the resistor for the LED. And then I've got this is the resistive divider for VBus. I've had to put it over this side because I can't really fit it over this side, which is where VBus is. I'm going to have to bring VBus out in both directions. Hopefully that's going to work. Right now it's looking like I'm going to get away with both, with the resistive divider rather than just the single resistor, which is good. That's what I'd prefer to do. Haven't figured out where this run resistor is going to go yet. But now I'm going to just route the traces for the USB just to make sure that all looks fine and valid. I'm also just going to double check these ground pads are far enough away from the edge of the board. 17 mils, so we're good. So I'm now looking at routing the USB traces. I realised I hadn't actually dropped a via through the board for the ground pad for the flash. I've done that. Again, it might move later, but I'm more interested in USB. Now I'm looking at D pluses on the right and D minuses on the left hand side. And if we look over here, I've actually got them the other way around on the electrostatic discharge diodes. So I'm just going to quickly flip over in the schematic so that D plus becomes this one and D minus becomes this one. Right, so we now have D plus on the right hand side, just where we want it. And let's drop a nice big trace in a fat via here. Can you go in the middle, please? Right, excellent. So now I can bring my trace a bit closer in. I know it looks like I'm being really pedantic in trying to get everything as close to each other as I possibly can, but that's actually really important for giving myself as much space as possible and also giving myself an aesthetically pleasing output, which I'm definitely after. Now, I'm slightly concerned here that I'm going a bit too close to the ground, the USB's ground pad. I would love not to do that, but I can actually route a trace out into the ground pour like that. And I don't even get in the way of pin 4 because pin 4 is not connected on the micro USB connector. I can connect up VBus there from the electrostatic discharge diodes through to the Schottky diode. And then I can route these traces. Don't really care about the connections for these two legs from the micro USB connector. They've both got two connections anyway, and they're obviously connected in the body of the connector via metal, so getting a good connection here isn't particularly important. Oh, you'd also notice I got rid of my spare traces now, traces that I moved from the board. That's just because all of the air wires, these white lines, show me where things need to be connected and aren't currently, but just getting in my way and making it look messy. And I'm confident enough that this is going to work now to progress without those. Some other things that I've done, I've installed the bypass capacitor for this 3.3 volt pin of the RP2350. And this is actually a much bigger, this is a 4.7 mic rather than a 0.1 mic capacitor here. And that's so that I've got the voltage regulator producing the voltage in the top left here, and it's coming and being fed around this ring, and it's coming through a fairly thin trace there, so that I have some charge on the 3.3 volt rail sitting on this side of the board coming into this side. So if there's a lot of drain on the 3.3 volt rail, this capacitor can help feed that drain. I've done it on the other side of the board, so hopefully that will help. Again, I'm not an expert on this stuff. Maybe it won't, maybe it will. The other thing I've got to do is I've got to get VBus over to here, the VBus detect pin. I need to figure out how to do that. I'm also going to need to figure out how to get 3.3 volts to the LED here. I'm probably not going to worry about that for now. But VBus, I've got two choices, right? I can go like this, or I can go like this, underneath. I'm going to go underneath because, again, these two legs are connected together with the body of the micro USB connector, so they get good connectivity that way. So it doesn't matter really if I separate the ground plane here. I'm going to use a thin trace because there's no reason in using a thick one. This is not carrying any current. It's literally just so that the pin on the RP2350 can detect that USB has been connected. I'll probably move that over there so I still get 2 connections on this particular ground pin. These pins, these data pins, are going to have to come down here somehow. Maybe they can come down across here. But then these are going to have to get up there. And they're not going to be able to cross. Normally, if you want them to cross, you have to go on the other side of the board. It's a 2-layer PCB. This is the second layer, or the first layer. It's not going to work. And it's absolutely non-negotiable that these are used for the image select jumpers, because these pins are not 5-volt tolerant. So physical pins 40 through 43 are non-5-volt tolerant pins. So they have to be used for the image select jumpers and also the LED. That's fine. I don't think there's any way in which I can rotate the RP2050 to get those closer to the top of the board, to the image select jumper, the physical jumpers. Because the whole point of my layout is I've rotated the RP2350 around 180 degrees so I can put the voltage regulator, supporting circuitry and the flash down at the bottom here. So they're going to have to get up. That's just something I can't avoid. So I'm reaching the conclusion that these pins here that are currently data pins are going to have to be used as address lines. I can probably get that one down to here if I use a 6mm trace. All right. So those can be address lines, and they're actually pretty close to address pins. So they really don't need to go very far. They don't need to span the board. It's spanning the board that's going to be difficult because of these big fat 1.1 volt traces. I can move a bit, but I need them. And I also need some stitching vias, ground stitching vias through the board to help connect the grounds together and also dissipate some heat from the RP2350. So, and then if I look at the other side of the board here, it really would be a lot easier if there were these 8 GPIOs. 1, 2, 3, 4, 5, 6, 7, 8. Those 8 I then take down to be these data lines, and I don't have to take most of them past the 1.1 volt traces. So I'm reaching the point where I'm going to have to make a decision. This is a one-way door. This is Jeff Bezos's way of talking about decisions. You've got some decisions that are 2-way doors that you can essentially, if you make the wrong decision, fine, you can go back and change it. One-way door is a decision you can't change. I can't really change it. Once I've committed and started laying out the board with the data pins being this lot, it's going to be an awful hassle to go back again. So that's why I'm just avoiding making the decision as late as possible. And also it's going to have a performance impact on one ROM. I don't think it's catastrophic, that extra cycle that it will take to shift the address lines, 8 bits. So I think I'm just going to have to bite the bullet and do it. But I'm going to stare at this a little bit longer, see if I can find any other way of sticking with the first 8 GPIOs. Or sorry, the first 16 GPIOs being the address lines. I've mused on this and I'm convinced that this is an inevitable consequence. I'm going to have to put the data lines to be the first 8 bits. And the causal chain is I had to rotate the RP2350 so that the voltage regulator circuitry, the flash, and in particular the USB lines could all come out the bottom rather than the top because there's more room down here. That led to me having to rotate the chip. That's led to these non-5-volt tolerant pins down here, which I can't use as data and address lines, being in the bottom left. They have to get up to the select jumpers if I want to use them at all. And I want select jumpers because they're cool and useful. So that means they have to get up there. And that means that these pins here, or these pins here, have to break out left of the circuit board. And therefore, unless they feed the pins that they're right next to, they're going to have to go somewhere else on the circuit board. And I'm going to get the select pins or the select lines and these lines trying to cross.
only way your traces can cross is by going on a different layer. I want this to be a 2-layer PCB. The top layer is completely taken up by the chip and pulling the traces out from the board. So there is simply no alternative to changing the first 8 GPIOs to be the data lines. So down here, and then have those route out that way down the board. So there's no alternative. I might as well get on with it. The first step is to go into the schematic and set the pins to be as close to the pins as I think they're going to be. So if we look here, A7, I probably want to be pin D2, A6 become D1, and A5 become D0. I'm just thinking I'll break them out there and I'll pull them about in the same direction. They don't need to cross, great. And then these 5 pins are they're going to want to be these ones. And again, I can make some judgment about which of the pins are going to need to be the various address pins right now, given how everything is falling out. I may tweak them later, but I'll probably get 75% of them right now. I have remapped everything. So I'm going to reload the pin layout into my PCB, and we'll see it's now magically changed those vias to refer to address lines. And I didn't actually use quite the same mapping that I said I was going to use. I said this was going to be pin 0, so it could route down easily to there. I'm going to try and do it like this, because here GPIO 0 is D0, 1 is 1, 2 is 2, 3 is 3, all the way up. So there's no, so the data lines are actually assigned in the order that the byte needs to be stored within the RP2350, which is how it gets served. So there's no mangling that's required for this particular hardware revision if this works. I've also mapped all of the other address lines to where I think they need to go. I think the routing is going to be fairly straightforward. Famous last words, but let's see how I get on. So now I'm just going to start routing. Okay, this is actually turning out to be more complex than I thought it was going to be. I don't have a lot of room to break the vias out. I have enough room to break the vias out, but if I say take D0 and break it out all the way over here, then I can't get D3 even on the underside of the board down to there. So that ain't gonna work. If I break it out here to leave room around it, then obviously I can't get this trace out. So actually I think my mapping is going to need to be different. I think I'm going to want to take these 4 pins and map them down to D3, D4, D5 and D6. And I'm going to have to take these other ones across the board. I can take some tracks across the board, just not very many. I think I took 7 across the board in the previous design. I'm just going to have a quick look. 1, 2, 3, 4, 8. I took 8 across the board in the previous design. I may not need that many here, but I'm going to need some. So my data pins are not going to be laid out in the order that the bits are stored in RAM, if you see what I mean. I'm going to have to do some mangling of the image still before I install it on the RP2350's flash. But, c'est la vie. So, D0, probably down to D3. So pin 2 down to D3, pin 3 down to D4, and so on. Probably. Again, I'm may mean crossing, so I may have to redo it, but let's give it a go. So D3. I need to worry a little bit about the ground plane and not disrupting the ground plane too much, but that's not really a concern at the moment. At the moment, I just want to get the damn traces routed. So I'm just going to go any which way, and we'll worry about fixing the ground plane later. I have a high, not just like the probability of getting this sorted is not 1, but it's I have reasonable confidence that I will be able to get it sorted. So I'm just going to route them all this way for now, and then 5. I'm going to put him here. Can I get him through? Oh no, but I probably can if I do this. Now you go through, and I can drop that one. I mean, he doesn't need to be a via necessarily, because what I need to do is just get him through to there. So let's just route him direct for now. Pausing because I'm going to have to do something about this bloody ground. Maybe I'll veer him. I'll veer him for now. And then you're going to need a veer. And then you're going to need to do something like that. Right. So I've got 4 of my data lines connected. Oh, I haven't got D5 connected. Why didn't I connect D5? Because I can put D6 in a way. So he needs to be shifted over to here. I'm starting to get a little bit uncomfortable about what I've done. I might not be able to make all this add up. But actually, the ground here is connected to the ground port that goes all the way around the edge of the board. So this should be okay. So I should be able to get a trace through there. I might have to move it a little bit. Right, you'll fit through now. And wow, I'll go this way. It doesn't really matter. I'll fix this up later. There we go. So that's 4 of my data lines routed. How am I going to get D7 connected? With difficulty. So what I need to do is push this ground veer over to here. I think. And then I can at least get a trace on the underside of the board through here. So if I take that trace to there, D7, and now on the underside of the board, I've connected it. Excellent. Remember, I already said that I might need to move this bypass cap, rotate it and slide it up a bit just to get it out of the way. I'm going to do that now because I'm fairly confident that's necessary. And yes, I am using every possible thousandth of an inch tolerance that JLC will give me with a PCB fab. So minimum traces of 6 mils and minimum clearance of 6 mils, and then 15 mils from a trace to the edge of the board. That's the standard spec for all the cheap fab houses. I'm using that. Yeah, ideally I wouldn't use that. I'd use bigger traces. I would have bigger gaps between them. But needs must. It's a very tight layout, and it's not my problem if the JLC can't make the board properly. It's fundamentally their problem. They must have some level of additional tolerance within there. Now I'm looking at this now and thinking, well, is this actually going to work? Because I've got to take these 3 traces out that way, out right, and I'm not convinced I can get 3 veers in there. I'm pausing there to go and have some lunch. It's about 12:15, so I've been at this for about 4 hours. That was with the schematic updates and fiddling around with some recording stuff. That took about the first hour. And then I've been spending about 3 hours on layout so far. And I think I'm within shouting distance of getting this done. It's going to take many more hours to do, but I'm reaching a high level of confidence that this layout is going to work at this stage. That's what my gut is feeding me. It's telling me that it's doable. I haven't yet looked at the test pads. That's the main thing I haven't done. I mean, obviously there's a boot run resistor I'm going to need to put somewhere. Might be a little bit problematic. Let's assume we can get that done. If I have to, I can just stick test pads all over the board on the underside rather than having them in a nice neat line like I achieved them on the STM32. So reasonable confidence this is going to work, and I'll come back after lunch and continue. So while having my lunch, I remembered that it's not just as part of moving the address lines away from being the first 16 bits, it's not just the fact I'm going to have to shift them, I'm going to have to mask them as well. Because today I'm doing a half word read, which just gives me the first 16 bits of the GPIOs, all the address lines. So I don't have to mask them, I don't have to shift them. Whereas, because I'm now starting at GPIO 8, going up to 23, I'm going to have to shift them and mask them. However, that is still, I think, only going to consume 1 cycle, because I'm fairly sure there's an instruction on the Cortex, is this M33, where you can do both in 1 instruction, which I think is 1 cycle. So that's not a problem. Anyway, back to the PCB layout. Where was I? So I've connected up these top pins. I've still got 12 CS1, 10 and 11 to connect. Well, these ones are dead easy because they don't need vias. So I'll get those connected.
10 and 11 are probably going to need vias. So let's just do that now. Okay, so 10 and 11 are connected. And then I need to get 2, 1 and 0. Ah yes, I remember what I was doing. I was seeing if I now had enough room to do all of this. So let me just shift these traces a little bit. That's just not helpful, is it? Right, that's more helpful. So if I put 10 all the way over here, like that, and then I can shift 11 right over as well. Oh dear, come on. Right. Then I can also move this 3.3 volt trace a bit more out of my way. In fact, the bypass cap is probably going to be able to move back down at some point. I might as well do that now, actually, thinking about it. So I probably want to grab it, drag it. There we go. You can come there. But surely I've got enough space in here now for three tiny little vias if I use the right traces. So I'm looking at these and just thinking they're probably the wrong way around. I probably want D0 to actually, the one that's currently D0, pin 8, to go to D2. So let me just swap those around. Now there's a lot of grounds in my way, so I'm just gonna go around them. No, I didn't want to do that. Okay, that's a bit of a problem. This 3.3 volts is squarely in my way. I'm going to leave it like it is for now. Sort it out later. Okie dokie. That via there might get in my way. Yeah, this 3.3 volts isn't in a very helpful place. So now at this point, I'm going to move these 1.1 volt vias and put them in the center, and this will give enough room for the ground pour to go between. I'm just going to note that I'm putting data lines directly underneath the inductor for the main voltage regulator. I'm not super happy about that. I would love to avoid that. I can't remember if I think I didn't have any data or address lines underneath that in the previous iteration. No, I had nothing under the inductor previously. So I'm not super happy with putting a bunch of noise on, what are they, data lines. So I think I'm going to have to route them somewhere else. I would love to get them through here, which I think can be done. If I do this, that should give me enough room to get those traces the other side of that ground via. Let's try it. Now it's not as easy as it looks because those jumper select pins need to go somewhere. In particular, that LED needs to come down to the LED, but one problem at a time. Right, I've avoided the inductor. Yeah, I've got oodles of space now because I've got to get those somewhere. And what I'm most concerned about is the LED. It doesn't have to be that pin, but it has to be one of them. So I can change cell C to be the LED, and we've still got another. We've got V-bus to get up there, haven't we? That is going to be a problem because I can't get both the LED and V-bus up there. I can bring one of them around the outside, but I can't bring them both. I don't have the room. Have a solution. I can take cell C, instead of taking it via a via, I can take it this way. Bring it in here,
drop it through the board there. Similarly, can I get that one through as well? No, there's not enough room to get it down there. I could take it around there if I'm happy cutting up the ground plane, which I'm not super happy about. So I'm going to continue to see if there's a way I can do this. One trace, of course, I can get around the side. So let's do that, and let's do it on the top side, and we'll leave the bottom side for ground, and we'll stitch it together with some ground vias. So that's my two signal lines. Now one of them I was going to turn into my VBus detect. So I'm pretty sure it was physical pin 42. I need to go and look at the data sheet. And you see we now can just connect VBus straight up. And it's going around there, so we want some ground vias. Let's find a ground via. There's a ground via. So we'll just stitch that together. Put one there, actually. We can perfectly reasonably, I think, put it there. And another one. We'll put him here and we'll drag him into place. It's good. So we've got nice good connectivity now between the ground plane on the top side, routing via the bottom. So we still need to place our run resistor. I don't want to forget that, because that is probably going to be problematic, because I don't have a lot of space left on my board. So I thought at this point I'd take a quick look to see if I can actually get a USB-C connector placed. Look how much bigger the USB-C is from micro USB, just to put that into perspective. And even if I overhang the board more, I still can't do it. Can't be done. I just don't think it can be done with this design. There's one constraint I'm just not prepared to move on at this point, and that's the pin pitch of the image select jumpers and the X1 and X2 jumpers. They're 2.5 more 4mm pin pitch, which is totally bog standard pin pitch. You see, it's the same pin pitch as used for the ROM itself going into the ROM socket. And pin headers for that pin pitch are a dime a dozen. And look at the pin jumpers. I've got hundreds of pin jumpers for that size, because they're the most common and they're super cheap. I want to stick with 2.54mm pin pitch headers. Someone suggested in a recent video that I could drop down to 2mm. I could even drop down to 1.27mm, a 20th of an inch. I could, but I really want to avoid doing that. I'm trying to make this as easy to use as possible. I totally get that people are trying to now standardize on USB-C connectors, and USB-C, so micro USB is a bit of a pain. It is. But what are you going to do? I literally don't think there's enough room on this circuit board unless I relax that constraint of 2.54mm pin headers to put USB-C on there. I just don't think it can be done, because the connectors, it's just bigger. It's a bigger connector. It's deeper. It's substantially deeper. It's probably a couple of millimeters. And I know it doesn't sound like a lot, but what's the difference? So that position there versus that position there is 2mm, basically exactly. It's also wider. The keep out is nearly 2mm wider. So that's 2 times. I can't figure it out in my head. It's probably like 10, 20 square millimeters. That's a lot. Can't do it. Can't do it. If you would like to design your own One ROM that has smaller pin headers and has USB-C on it, go for it. You can absolutely do that. You can have different pin mappings, and it can all still be fully supported with a specific JSON config file for your board. But I'm doing it this way with micro USB. I turned into a bit of a rant. It wasn't meant to be a rant, and I have nothing against people who are suggesting using USB-C or using smaller pin headers. It's not what I want to do. I want to keep the pin headers as they are, and that means sadly I can't use USB-C. Anyway, I want to figure out where on earth am I going to put this run resistor. So where is the run line? The run line comes out there. My current thought is I don't need all of these vias here, because most of these traces are going to be able to route directly to these pins without needing vias. And therefore maybe I can squeeze this resistor in here, which is pretty close to there. So it might work. That's my current thinking. So I'm going to try and route all of these different traces right now. And because I want to do without vias, if at all possible, I'm actually going to take this physical pin 35 and not map it to A0. I'm going to put it on A1 and then take this one round here to A0. So I need to swap those around on the schematic. One ROM just supports essentially arbitrary assignments of any address line and any data line to any pin within. There are certain constraints. One ROM supports, within some constraints, mapping any address line into any GPIO, as long as it's within a certain chunk of them. I can rearrange them as I like, and then the ROM image gets stored on one ROM in a way that when the address lines are read, they can be used as an index without doing any remapping. So essentially I'm sort of pre-mangling the ROM image before it gets stored to one ROM, so that we don't have to do any kind of demangling or extensive CPU intensive operations in one ROM. Happy with that. Right, I think a resistor will go in there. Whether I can get a via in as well, I don't know, but can I get a trace up there? Let's have a look. I can get a trace through there. Yes, and I can get a via there. Yes, excellent. This is going to work, I think. Oh no, I'm going to need... Oh no, I still need a via. Because I need to get to the test point somehow. I don't think this is going to work. I don't think I can get the trace in from here down to this resistor, from this via to this resistor, and also via this run pad to underneath so I can connect to a test pad. I just don't think that can be done. I'm not super worried about the run test pad, to be honest. I just need, do I need to have it connected to a resistor? I'm just going to have a look at the schematic. No, I don't need to have it connected to a resistor if I don't break it out of the board. It's essentially a reset pin, and I've never needed to use the reset pin on either STM32 or RP2350 versions of One ROM. So I could probably do without it. The other option I've got is I could put the resistor over this side of the board. Probably I can probably find space over here. I route this up round here and then over to here. So I've got room for a resistor. Here you are. Let's get rid of that. Don't need that. It's in the wrong place. So let's move that over. I've replaced all my bypass caps. Right, that's good. So run. So remember, we've got two things here. On the left-hand side, this goes to the pit. No, it must go to the test pad. And the right-hand side must go to the pin itself. So I'm actually going to rotate this around. Do I want to take it around the top like this, or do I want to take it around here? I think I want to take it around the top. The reason I'm saying that is partly so I can get close to these pins here. And I'll drop it like that. But also partly because if I take it around this way and then connect it up to here, I'm gonna cut off the ground plane at that point, which I've not done in routing the trace round in that direction. So we've still got a ground plane going around that 1.1 volt trace. So that looks good to me. And I need to break that run out to a test pad. I don't have a lot of room for test pads on this board. But I still need some stitching vias under this damn RP2350. So I'm going to put those in. I'm going to put some of those in right now before I forget. I've got room for another couple of traces going that direction if I need them to. Remember, I can't get any trace at all coming through the board in the other direction now, because, well, I just got nowhere to cross these particular tracks. When you take tracks across the board like this and you've only got one layer to route on, which is all I've got, that's it. All the tracks have to go in that direction. I'm a little bit worried about how many air wires I've still got flying around. A bunch of them are these test pads. That's fine. Some of them are the select lines, which I need to route. So some of them, well, maybe I can take them up here actually. This would be a better place to take them up. If I can bring them up the left-hand side of the board, like maybe not with that thicker trace, but bring them up the board to here. And then my plan has always been to drop vias through here and then go to the top side of the board and route to the pins I need to route to. I'm going to give us a cell D on the schematic now as well, because this spare should now become cell D. I spotted a problem. These vias here need to route to these pins. So I should do that right now. So that's going to go up to here. I've got all the other pins connected. Can you see the problem yet? I have to get these cells up to here, but I cannot get them between that via and that via, and I can't split them apart to get my traces through. I can't really via them here underneath the voltage regulator because it's going to destroy my ground. But I've got to get them to here. I've got to get them to here. So this is the trace that's my problem. And that was the resistor that we just placed over here. So it just can't go there. Because this run resistor and the run pad are not absolutely critical, I'm going to take them off the board for now. And I'll come back to them at the end to see if I can figure out a way of getting them on the board. But at the moment, it's not looking like it can be done. So the run resistor goes out of the way with the run test pad. So now I can route these cell pins. Another problem this is going to give me though is I'm going to have to bring them through here. It's going to split my SWDIO and SWClock, the SWD pins, which I want to go to test pads. So the SWDIO test pad is going to have to go, I don't know, here maybe, or here, basically on the left hand side of the board, and the SWClock one is not going to be able to be right next to it. Unless I bring them both down somehow, and I don't know how I'd get them routed, I think they're going to have to be separate. But test pads, not as important as core function. Let's get the core function routed. I'll tell you what, it's going to fit. Whether it fits or not, it's going to fit. Okay, I'm maybe a mil out. You get to this stage of a circuit board layout, because you've got traces all over the place on the top and the bottom, even though it might physically be possible to move everything over, you can't do it because they're all getting each other's way and you can only move one thing at a time. But let's see what I can do. Oh, that moved quite a lot. Yes! That's easily given me... Actually, it didn't give me as much as I thought I did, because I've got to go up that red trace there. But that's enough. Right. Come on. And he fits through there. Perfect. Brilliant. There's not many air wires left. That's a bit of a concern. A 3.3 volts not connected. That's because I've not connected it. Let me connect it to the ring on the inside. That'll get rid of that air wire. Yes. Right. There's still net. Okay, that was because that one's not connected either. So let's connect that one too. Okay. So even though I had this bunch of things I haven't connected, mostly test pads, I'm actually looking for things that aren't test pads now, that air wires. I'm going to get rid of these spare traces and vias. I can always recreate them if I need to. The boot, that's to a test pad. So if we think about what use I'm going to be making of the boot jumper, I can't remember if you pull it down or up on the RP2350 to force it in boot cell mode. On the STM32 you pull boot 0 up. I think it's the other way around on the RP2350. because boot is connected to, boot is connected to the flash chip select line through a resistor and then pulled up to 3.3 volts. So it must be pulled down to enter boot cell mode on the RP2350. So I need a ground pad right next to the boot pad, and there's a ground pad there. So those will want to go next to each other, and ideally I'll want to have vias through the middle of them. The reason I might want vias is because it's much easier to, say, get metal tweezers into a test pad that has a hole in the middle of it. I found that with the STM boards, that actually it's quite hard to jump a boot 0 to 3.3 volts if they don't have holes in them. But, you know, again, I can only do what I can do. I can probably put the boot test pad right there. Try and put it in the center of the via. So that's my boot test pad. And ground's easy, right? Because ground's everywhere. Put this test pad here. So they're close to each other, so they're close enough to get tweezers into. I've got vias in the middle of them, so that's convenient. It's not tidy because they're not aligned next to each other, not in a straight line, but it's probably good enough. Right, what else do I have in terms of air wires? Again, I don't worry about these test pad air wires, but let's put all the test pads. Right, so all the air wires are sort of going in the same direction. Can I see any other air wires? There's obviously design rules check that I can do later. Yeah, there's an air wire. V-bus is not getting over to there. Of course it isn't. I can see it's not getting over to there. So I need to squeeze those in here. And yeah, we've got V-bus, so there's no air wire there. Can't see any more air wires in this location. Got the ones going to the test pads. Yeah, it looks pretty good. Everything looks connected to me. I can't see any air wires. Oh, no, there's one. There's a ground wire. This ground here is not connected to anything else. So the way I'm going to deal with that is I'm going to take a ground trace up this side and this side of the unconnected pad. And that will give me a nice thick connection. So this gives me a total of 15 milli-inches trace between those two tracks. So that's that air wire gone, because that is now connected up. I said earlier that I would like to bring 3.3 volts kind of around the board if possible to feed in to this 3.3 volt ring underneath the RP2350 at multiple points. I've not been able to achieve that, and I don't really see a way of getting 3.3 volts sort of round here. Everything's just too busy on the board. It's possible I could achieve it if I drop through to the bottom, but then I'd be probably taking it around the edge and breaking up the ground plane. So I don't want to do that. And I've convinced myself that this is going to be fine, because we get 3.3 volts coming out of the voltage regulator here. It goes into a 4.7 mic capacitor and a 0.1 mic capacitor here, and then goes into this ring. So only through an 8mm trace. And then one of the areas where it comes out into a 3.3 volt track is this 4.7 mic capacitor on the other side of the board. So this will store a decent amount of charge. So if there is a lot of demand all of a sudden for charge from the chip, it can be fed through this track as well. Now, that doesn't help for steady state. If steady state it's drawing more current than can be supplied by an 8mm track, well, I'm screwed. If I can get 3.3 volts over to somewhere else and feed it in, I will. But I'm not seeing it right now. I'm going to take a note, come back to it. It's got to come from here, top left really. I can definitely drop it into a via here if I want to. But look at that, I've got myself another 3.3 volt feed into the chip. So I'm now 8 plus 6. 8 here going into this ring and 6 here. So that's 14 square millimeters of power, which is good. I'm happy with that. That's a good result. Hopefully I haven't screwed up my grounds. It looks like I might have done. Let's have a look. That ground is no longer connected to this. Yeah, come back to me on that. I'm sure you had no doubt, but I got it done. I had quite a lot of doubt. I've managed to rotate this bypass capacitor round. It was up like that, and now it's on its side, just by squeezing this 1.1 volt via and reducing the track size slightly. I can probably put that there. I managed to get it turned around. I managed to get these two vias on top jigged around a bit as well, and I think it's all good. I think that works. I have even less space now for the run resistor though, I think, because I was putting the run resistor here at one point in the past, and I've got a 3.3 volt via. And where else could I get that track there too? Well, coming up here is no good unless I get rid of this header here. I can get it through, can't I? If I move these traces like this, then I can get that to come to here, and I don't need that extra header because I don't have a spare GPIO, so I can fit test pads and the run resistor there. So that's what I'm going to do. Alright, I've updated the schematic and I've created a new footprint for the 2x4. The reason I need a new footprint is because I had custom silk screening on it. So now I need to replace the one that's already there. So I'm going to put it in exactly the same spot and then delete the existing one. That should be good. And now I've got a load more space on my circuit board. To be honest, I'm not sure I want to use it for the run pad because it's lovely, clean, free real estate, but I'm not quite sure what else I'm going to do with it. I'm still faced with that problem where Swcluk and Swidio are going to need to be relatively far apart on their board. But before I get too distracted by that, I'm going to route run to where I just made room for it. A few things. I'm going to do without an MCO pad. And the reason why is on the, I've checked the datasheet, and the RP2350, you can actually drive clock outputs. So you can examine, the PLL outputs and inputs and various bits of the clock using a number of different GPIOs. And you can use GPIOs 24 and 25, which I have as cell B and cell A. So if I needed that debug output, I could actually use these pins that I already have exposed. So I don't need MCO1, so I'm going to go and delete that test pad from my schematic. What else am I looking at? I haven't connected the run pad up yet, so I need to do that. I'm going to need to take this back down through a via to achieve that. Well, the easiest way to do that is presumably not to use a massive fat trace, but instead to stick a via right in the middle of the pad. So that actually makes that pad easier to use if it's got a via sitting in the middle of it. Obviously I can't put a via in the middle of Swidio and Swcluk because there's other things on the other side of the board. So that is what it is. It's going to tidy up my traces a bit. When I get to this stage of PCB routing, I'm basically done. I know that I've got a good design. I haven't run the design rules checker yet, and it may well throw up a few places where I've got, I don't know, vias too close to tracks or whatever. Some places where the KiCad didn't manage to prevent me from doing the wrong thing as I was laying things out. But I broadly know that this is a design that's going to work. So I start doing a lot more tidying up at this point because I know tidying up is less likely to be wasted time. So I'm now looking at this and I'm going, there's a bit here which doesn't have ground in. What's the best way to solve that? Well, I might as well just take this 5 volt trace down there instead, and then this gap here gets filled with ground. I mean, I could also move this Swidio test point. I'm not sure it absolutely needs to be in that position. Where can I sensibly put it? And actually, I do quite like the fact that it's at the same vertical height as Swcluk. Actually, I'm not sure it is right now, but I want it to be. So that's too close. That's not a bad place. And I'll just set the origin so that I can get this one at the same height. So this is actually at the same height now, apparently. Let's just check that. Yeah, it is at the same height. Yeah. And I can move this one that way, get it out of the way a little bit. Again, I don't want this super close to those traces. That's fine. That will do just fine. At this point, I think the circuit board's done. It's functional. It's going to work, assuming the design rules pass. So that's the next step, is run the design rules. And then at that point, I'm going to take a look at the 3D view of the board and see what I think about it. See if there's anything I want to try and change as a result of how it actually looks, whether the aesthetics appeal to me. All right, I've got the design rules checker up. And this is probably going to throw up a lot of unconnected track ends where I've just not quite connected things together properly, or there's extraneous bits of tracks I need to delete. I'm not interested in that. What I'm interested in is unconnected items and any tracks or vias where I'm not keeping to the clearances that I've defined, that are essentially required by the PCB manufacturer. So I'm running the rules now. Okay, I've got one unconnected item. 5 volts is not properly connected. And I've got a whole bunch of cases where power I don't have the right clearances on. So these vias are connected on one layer, that's fine. That's just where I put a via through a test pad. I'll get rid of that. And this one as well. I've got an unconnected track end, which is probably here. It's probably the smallest one. If I delete that, it becomes deleted on the design rules. I care about these ones, these clearances, and there's a few of those. That one's the most worrying, so we'll have to come back to that and look at it. It could well be the ground via here, in fact. Let me just go and have a look at that. So if I grab that, yeah, there we go. I think it will be fine there. So if I rerun it, that one with the 2.62 mil clearance should disappear. So let's run that. Okay, the rest of them are under a mil out, so hopefully I can find under a mil where I need it. Courtyards overlap, that's fine. Essentially, I don't have quite the right courtyards defined for some of my components. We'll take a look at them, but I'm pretty sure these are all fine. Board edge clearance violation, I'm not worried about this. I should have 15 mils defined in my board setup because that's the PCB manufacturer's requirement, so I can get rid of that just by changing the constraint. I don't see any more errors. The rest of these, well, there's thermal relief errors, they're fine, don't care about those. Silk screen overlap, don't care about those. Okay, so I'll change that edge clearance violation. I'll just change the constraint. We'll need to look at these clearance violations. I need to look at this unconnected item. So the first thing I'll do is I'm just going to go in and change my constraints. And this will be the first time you've seen this window. So this is where you actually go up and set up your constraints for your particular board. And I'm looking for the edge clearance violation. Minimum vias, copper to hole, copper to edge. There goes 15. Should be 15 for this board. And I tend to set these to round numbers of mils. So I obviously haven't done this for this board. I don't use micro vias, so I don't care about those. I actually do go with smaller text than this, so I'll make this quite small. Let's have a look at this unconnected item, see where it is. Okay, so that's very easy to fix. I haven't connected the capacitor required on the input voltage on the voltage regulator up to the regulator itself. So I'm going to do that. I don't think I can use it. Oh, I can use a 24 mil. I'm not going to. I'm going to use a 12 mil. That'll be perfectly sufficient. So that should get rid of the unconnected item. So it was one air wire that I couldn't see when I was looking through the board. See, now unconnected item 0. Fantastic. Now we just have 6 clearance violations to resolve. So let's have a look. Okay, one of them is this test pad, and I can immediately see that that's in a bad place, and that's really easy to fix because I just need to move these traces out just a smidge. One of them should have disappeared. I should now have 5. And then number 5. Right. Oh dear. Well, this is a very critical part of the circuit board, so I need to worry about this. My guess is there's not enough room here and not enough room here. Don't know quite why it allowed me to lay it out like this. Let's have a look. I'm going to delete the trace. What trace widths do we have here? They look like 9 to me. So let's go to 9. See if it will actually let me. So it won't let me connect it at 9. Right. Right. I think it's going to be happy with that. Find my design rules again. Are we down to 4? Oh, we're down to 3. That killed 2 of them. So we still got 1 here though, I think. Yeah, we still got 1 here. So where is that? It must be this trace. So let's try redrawing that trace. What happens now? Down to 2. Oh dear. Oh dear, oh dear. So this trace here can't go any further left because of that ground pad. So hopefully the Schottky diode will move by 1 mil right. I think it will. Should be down to 1. Oh, none. We've got none. Fixed it. Good to go on design rule checks. I'll rerun them just to make sure. But yeah, I've got just sort of still screen warnings. I've got no unconnected items. So yeah, deleted the markers and I'm good to continue. So where do I go now? I start looking aesthetically at the board. Do I like the way it's laid out? Do I like where all of the traces are? Do I like where the components are? Are the components all lined up as well as they can be? Obviously I've got constraints as to where the components can go. I like to have my boards looking really nice. So it's now about 2:30 in the afternoon. So I've spent another couple of hours on this since lunchtime. So total I've spent 6 hours on this board so far. And I have a board that I have a good confidence is actually going to work. It's going to continue working as a One ROM, and I can also get USB connectivity working on. 6 hours. How long is it going to take me to get to a board that I'm happy with? Well, that's the question, but it could be many more hours from here. Go on then, you can see the 3D model as well. This is as it is at the end of getting the design rules all passing. So we've got the main voltage regulator, the 5 volt to 3.3 volt regulator here, the crystal oscillator here, the Schottky diode for the retro systems power supply here, the RP2350 slap bang in the middle, the flash, the 2 megabyte 16 megabit flash, the polarized inductor required for the 1.1 volts on the RP2350, the micro USB connector, the electrostatic diode, electrostatic protection diodes, the Schottky diode for the incoming power supply from USB, and the LED, and everything else is passives. As you can see, it's a bit busy. There's an awful lot of components on here and they're quite spread out. The spread outness is really as a result of the fact that it's difficult getting the traces from the RP2350 and that I'm using a 2-layer board instead of probably a 6-layer board would be required if I wanted to get everything a bit more compact. I don't think 4 layers would really help for reasons I've shared previously. But on the face of it, this looks pretty good to me. The sorts of things I'm looking for are gaps in the ground pour, like here and here and here and here. And I'll see if I can get those looking a bit cleaner and filled with copper. In general, I like them to be filled with copper. To be honest, I'm not going to be able to see this with the native eye. I'd like to find somewhere on the circuit board on the top where I can put one ROM and also the hardware revision number, PB, actually, or PB1 maybe, we'll see, on here. That would be ideal if I can get both of those things on here. Let's look at the other side. In fact, I'm going to turn off the through-hole components just to make it a bit less busy. So here we can see that we have the underside of our jumper pins. I'm going to need to update that silk screen to be D because we've now got 4 jumper pins. We've got X1 and X2. I'll need to figure out a way of labeling these test pads. That could be quite tricky for some of them, like these two, actually fitting in some kind of lettering here see how I get on. And then I've got the other ones here. These are the main ones. This is boot and ground, so you can jumper the two together if you need to unbrick the device. I've got a little bit of untidiness in my traces here, so I've got some gaps in the ground port around the X1 pin, and also down at the bottom left. This is actually the bottom right if you're looking at it from the top, so I've got that to clean up. I don't know why I've got an extra via in here that there's nothing connected to. That seems a little bit odd. I'm just gonna have a quick look at the... Oh, interesting. That's V-bus det. So the detection of V-bus, that's actually extraneous. Alright, so I should have got rid of that via. We just see it magically disappearing. We can see my 6 ground stitching vias underneath the RP2350. That's 3 times as many as I had on the last board. The other thing I've got to figure out how to do is get the silk screening on the underside here, where I want one ROM again, and I want copyright statement if I can, and a few other bits and pieces. So a few things for me to do. I'm not going to bother taking you through that. I'm just going to sit down and make it a bit tidier, see what I can do silk screen wide, and I'll come back to you. I think I'm done with the silk screening and everything else associated with this board. I think I'm basically ready for fab at this point. Just to run through quickly what I've done, I've got one ROM silk screen and also the revision of the board on the front, and you'll see I've updated the PCB colour. I'm planning to fabricate the RP2350 boards in red, as I'm nicknaming them fire boards, and the STM32 boards will be the blue boards. On the underside, everything's silk screened. I've got the 4 image select jumpers marked A, B, C and D. I've got run and ground next to each other. I've got a 5-volt test pad which I've added because I had room to place that on the board, and I've got clock and DIO pads labelled. I've got 3.3 volt pads, 2 of them labelled, and I've got boot and ground next to each other labelled. Those are the 2 most important ones because those will need to be jumpered together to unbrick the board if it ever gets bricked. I've got the hardware revision on the underside, and I've got the URL of the project, the name of the product, copyright statements, and so on. So I'm pretty pleased with this. I think it looks really good. It's really neat. It should be functional because electrically it's very similar to the previous version. Obviously I've now got USB exposed. I've got the final spare GPIO connected to the image select jumper D. I've got a GPIO for detecting the bus voltage, the USB bus voltage. I've got the USB pins connected coming out here from the RP2350. I've got all of the supporting circuitry required for USB on here. Generally it looks fairly neat and tidy. There are a few components that are a little bit closer to the pins than I would like. Particularly this bypass cap is a little bit close to this pin here, and these 2 bypass caps are a little bit close to this pin here. But that's the worst that I do with this design. Then I still think that's pretty good going.